An Introduction to Rebar Lap Splices by Barlines Rebar Estimating and Detailing Inc. This short presentation will show you the factors affecting rebar lap splices in seismic and conventional detailing as practiced in the United States. We will visit lap splice classes and cases, air bubbles, bundled bars, and moment frame columns. There are three factors affecting lap splices. The first one is class A and B. Class A lap splice are shorter tension development length but requiring staggering of bars so that only 50% of the bar are lap spliced in a given section. Here, only 50%. Class B lap splice are longer tension development length, not requiring staggering of bars. Contact and non-contact. Contact lap splices are preferred. However, non-contact is also allowed as long as the clear spacing between bars shall be 1/5 lap length or 20% and no more than 6 inches apart, 150 millimeter. The second factor are case 1 and case 2. Case 1, the concrete cover, which is this and this concrete cover, is at least 1 bar diameter. And the bar-to-bar spacing is at least 2 bar diameter between the bars, 2 bar diameter in beams and columns. That is in beams and columns. In all others, the bar-to-bar spacing is 3 bar diameter. That's case 1. Case 2, the concrete cover is less than 1 bar diameter. And the spacing between bars is less than 2 bar diameter in beams and columns and less than 3 bar diameter in all others. So case 1 is you have equal to 1 bar diameter or 2 bar diameter spacing for beams and columns, 3 bar diameter in all others. Case 2, the cover is less than 1 bar diameter or less than 2 bar diameter spacing in beams and columns and 3 bar diameter in all others. That's case 2. The third factor is the position of the bar, top bars and other bars. Top bars and other bars. Top bars are horizontal bars, not vertical, but horizontal bars, with more than 12 inches of concrete cast below the bars. So top bars are just horizontal bars with 12 inches of concrete underneath it. If it has less than 12 inches, it's considered other bars, not top bars. So bottom bars of the beam are other bars. There's a certain phenomena that happens when you cast concrete under a bar or surround the bar with concrete. There's bubbles inside the concrete that makes it workable, especially in air-entrained concrete. These bubbles evaporate and goes up. Because of the air bubbles trapped under the horizontal bars, bond between bar and concrete is reduced, requiring additional length to take up the slack. Caltrans recognized this phenomena to be true to bundled bars also. Because of the gap, there's no concrete, and they provide for additional lap length also. Barlands is not making up this presentation. All of the statements here are either from the American Concrete Institute, the Concrete Reinforcing Steel Institute, the Portland Cement Association, Steel Reinforcement Institute of Australia, and the Office of Meinhardt in Australia. Typical resistant columns. This typical detail from ACI Detailing Manual 2004 clearly demonstrates the preference of Class B lap splice to allow for building columns into cages for easy installation. The only added provision is that such lap be enclosed with ties per 21.442 and 21.4.4.3. There is no restriction on location of vertical lap splice for intermediate moment frames. Both SRIA and PCA both chose the exact same detail. Seismic resistant flexural members as shown on ACI. These are for the beams. These are the beam sections. More configurations here. This is Meinhardt column in Australia. Columns are tied into cages on horses, and the column standing up. All lap splices, Class B, a longer lap splice with no stagger. More information available from CRSI Reinforcement Anchorage and Splices, 4th edition, 1997. Make a difference and learn all about lap splices and anchorage. Thank you.